Hello everyone, today we're going to go over the Blind 75 in C++, and today we're working with the insert interval. Now, before we get started, make sure that we have our 4 following questions already set up in place. If you want to follow along, feel free to pause the video. First, we need to ask ourselves exactly what our input is going to be, what data structure / algorithm / technique we need to use, what to do with the data, and what our output is going to be. Again, feel free to pause the video if you are following along to write out the comments for these questions accordingly. So now, when to break down the following problem, you are given an array of non-overlapping intervals where intervals I equals start of I, end of I, represent the start and the end of the ith interval, and the and intervals is sorted in ascending order by start of I. You are also given an interval, new interval equals start and end, that represents the start and end of another interval. Insert the new interval into intervals such that intervals is still sorted in ascending order by start of I, and intervals still does not have any overlapping intervals. And we may need to merge overlapping intervals if necessary and return intervals after the insertion. Okay, so based on the following problem, you're given an array of non-overlapping intervals. That's the start. You can also look at the parameters at the top to be able to see exactly what we are looking for. And then we're also given a new array of intervals to insert in the intervals array. And so it looks like from the following data over exactly what we need to do. We need to insert the new interval into the intervals such that intervals is still sorted in ascending order and all the intervals are non-overlapping. All right. And it looks like for our output, we need to return another interval where the numbers are not overlapping each other with the new inserted interval we are given. Okay, and so if we want to break down the following example, say for instance we have intervals equal 1, 3, 6, and 9, and we have a new interval 2 and 5, and our output is 1, 5, 6, and 9. It looks like from the following, since the problem also states that we may need to merge overlapping intervals if necessary, because we need to return the new intervals that don't have any overlapping intervals. So we have an intervals array, and then for our output 1, 5, 6, and 9, these numbers are non-overlapping. So the relationship that we are seeing between the input and the output is that, well, if we are given a new interval, we need to insert that new interval on the inside. So we would have 1, 3, 6, and 9. But since 2 and 5 are overlapping 1 and 3, this is why we merge 1 and 3 with 2 and 5. So we get 1 and 5 accordingly, and then 6 and 9, because all these intervals are non-overlapping and we insert the new interval. Now if we were to look over example 2, we have an array of intervals to start with and a new interval 4 and 8. Well, it looks like 4 and 8 merge within 3, 5, 6, 7, and 8, and 10. So these 3 different intervals are having 4 and 8 be overlapped inside of them, and we need to merge them accordingly, which is why we get 3 and 10. And so our output would be 1 and 2, 3 and 10, 12 and 16 as non-overlapping intervals. And the explanation is pretty self-explanatory, because the new interval 4 and 8 overlaps 3, 5, 6, 7, 8, 10, which is why we merge 3, 5, 6, 7, 8, 10 to get 3, 10, because we have 4 and 8 overlap these set of intervals. And so the technique for us to be able to solve this problem is going to be an iterative approach, which is a fancy way of saying, hey, we're going to scan throughout the rest of the array, and we're going to make a series of conditions to abide by in order to replicate the behavior for our input and our output. So the steps in order for us to be able to solve this problem is that for step 1, we need to initialize a new list for the result. In step 2, we're going to create a for each loop where we are going to iterate over the list of intervals. And inside of a for each loop, if the current interval does not overlap with the new interval and occurs before it, we will add the current interval to the result. So it would be like, say for example, if we were to have 3, 4, 6, and 9 as just an example. And if it occurs before, and then we have new interval equal 1 and 2, all that together, since it will occur before, we will get the output of 1 and 2, 3 and 4, and then 6 and 9. And then for step 4, we're going to do the same thing, except for it's going to be after. So if the current interval does not overlap with the new interval and occurs after it, we're going to add the current interval to the result and update the new interval to the current one, since we were scanning throughout our array. Array of intervals. So that would be an example of, say for instance, 3, 4, 6, 9, and then the new interval would be 10 and 12. So we would have the following: 3, 4, 6, 9, and then 10 and 12 accordingly. Then for step 5, in this case, if the current interval overlaps with the new interval, we will merge them into a new interval, much like in the case of example 1. So we would have that's how we do it. So the following example that we have, just want to space this out, and I'll also put this inside of the comment section as well. And then for step 6, what we will do is that we will add the last interval to the result and finally return the result. So to be able to give a breakdown on the following problem that we have, step 1, we need to initialize a new list for a result. So it's going to be a vector inside of a vector for int, and then we have result, given the fact that it'll be like 1 and 3, and then we have a vector that is containing other vectors as well. So here's another vector, and then it's a whole vector that we have. That's just how we do it in C++. And then step 2, we're going to create our for each loop. Well, it will be a for auto and interval inside of our intervals array. And then we're going to do steps 3, 4, and 5. Where we're going to have our if statement. Then we will have our else if statement. Finally, our else statement. Okay, now for step 3, if the current interval does not overlap with the new interval and occurs before it, well, it looks like for the current interval of 1 comes before new interval at that following index before. For if the current interval does not overlap the new interval and occurs before it, we will add the current interval to the result. So result dot push back for interval. We're going to put that in there. So that's what we do. And it will be much like in the case of here. Or it could be like another case of Okay, actually flipping these examples all together. So we'd have this one, and then we have this one, just to visualize. There we go. That's more like it, because it occurs before, and then we have this one where it occurs after. So that totally makes sense. And then we're going to update our following. All right, so then else if, in this statement, we're going to have our new interval, 1, be less than the interval of 0 accordingly. Then for step 4, we will add it. So if the current interval does not overlap the new interval and occurs after it, add the new interval to the result. So it will be result.push back for the new interval. And then we're going to have a new interval equal interval. And then finally for our else statement, step 5 is if the current interval overlaps with the new interval, we merge, and this is how we're going to merge. We're going to have the new interval 0, indicating for like the lower end, and then for the upper end at the same time. So this will be min. And then we'll also do the same for after. Oh, hold on, give me 1 second. Max of it. That's how we do it. So we're going to have a new interval of 0, and then interval of 0, and then we're going to have the max of the new interval to determine what it will be, or the interval for the max of it at 1, respectively. Make sure that we also put our semicolons already set in place to make sure the syntax already lines up. We're going to do step 6, where we will add the last interval to the result. That would be result dot push back new interval, after we have already checked everything and scanned through our rest of our intervals if it all matches up between our conditions. So this would be before, after, and then merge in this case. Again, I'll put all these steps accordingly inside of the comment section. And then finally for step 7, we're going to return our result, for we are creating a list as a result from everything that we have already created. So let me just clean this up for you folks to make sure we have already set everything in place. I'll put step 1, 2, 3, 4, 5, 6, 7. And again, I'll put this in the comment section. All right, also if 1 and 0, push back, interval and intervals. Yep. All right, it passes all the test cases. Let me just put this up for you folks so we can explain more about the space and time complexity. Double check. All right, and submit. Okay, now, just to be able to give a breakdown on space and time complexity for our following solution, is that our time complexity for our solution is going to be O of n, where n is the number of intervals, and we only iterate over the list of intervals once, while the space complexity is going to be O of n, given the fact that we are storing each interval that we have already visited into our result list. And so that's why in particular it will be O of n, for n is representing the number of intervals. And yes, so this was insert interval. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.